Okay, now we are in chapter 8. Topic for chapter 8 is spatial distributions. So this is the distribution, meaning that we are going to look at the data distribution, how data from sample or from population are distributed. Okay, dalam any type of research or kajian, data that have been collected, it have different type of distributions. So dalam kajian ada banyak jenis distribution, normal, binomial, Poisson and so on. So it depends on the characteristic of the data. Okay, so dalam syllabus ni kita akan tengok only a special distribution that are commonly used. Okay, one of it is discrete distribution. Okay, for discrete distribution, it consists of values that a discrete random variable can assume and the corresponding probabilities. So untuk discrete distribution, data-data yang kita collect tu berbentuk discrete. Maknanya kita boleh kira, it is countable. Kita berkira 1, 2, 3. Okay, macam bilangan orang, bilangan kereta, yang tidak mengambil decimal numbers. That is discrete distribution. Okay, the probabilities are determined theoretically or by observation. So it depends on how data has been observed, sama ada discrete ataupun continuous. So probability yang kita perolehi is based on theoretical, daripada formula, theoretically mean daripada formula, ataupun probability yang kita perolehi daripada observation. Observation meaning that out of 100, 20 berjaya. So probability dia adalah 20 over 100. Okay, two types of discrete probability distribution that we are going to look at. One is binomial probability distribution and second is Poisson probability distribution. Okay, for binomial probability distribution, probability yang bercirikan binomial ni sama ada event itu sama ada berlaku ataupun tidak, berjaya atau gagal, hujan ataupun tidak, macam tu. Okay, yes or no, lelaki atau perempuan. Sama ada possibility tu berlaku dua kemungkinan, ya atau tidak, salah atau betul, macam tu. Okay, suppose that a certain fast food restaurant is giving away a coupon with every purchase of a meal. 20% of the coupons entitled to a free burger and the rest say better luck next time. 10 students order lunch at this restaurant. What is the probability that 3 of them win a free burger? Okay, so dalam kes ni kita nak tengok sama ada dia dapat free burger ataupun tak dapat free burger. So jadi maknanya dua kemungkinan. So kalau dua kemungkinan, data tersebut behave as a binomial probability distribution. Okay, if we let X be the number of people out of 10 that win a free burger, then the probability distribution of X can be constructed. So kita akan define dulu random variable. Okay, so discrete random variable kita akan define, which is X, the number of people that win a free burger. Okay, how many of number of people out of 10 that win a free burger. So in this section, we will learn that X has a distribution called the binomial distribution, which is one of the most useful probability distribution. So X behave as binomial distribution sebab kemungkinan chances untuk possible event untuk X berlaku adalah sama ada dia berjaya win a free burger atau tak berjaya win a free burger. So dua possibility. So therefore X, random variable X behave as a binomial probability distribution. Example, according to a survey, 65% university students smokes. 3 students are randomly selected from this university. Let X denote the number of students in this sample who does not smoke. According to a survey, 65% university students smokes. 3 students are randomly selected from this university. Find the probability that the number of students who does not smoke. Okay, so kajian ni behave like a binomial probability distribution sebab it's either ada dua possibilities. Either the university student smokes or do not smoke. Dua possibilities. So dua possibilities, so it behave like binomial probability distribution. So now find the probability that the number of students who does not smoke at most 1. Paling banyak seorang saja yang does not smoke. From 1 to 2 who smokes. At least 2 who does not smoke. Okay. From 1 to 2 who does not smoke. At least 2 who does not smoke. Or find more than 1 student who does not smoke. Okay, using a tree diagram, we find probability from a probability tree diagram. So it's like the student either smoke or do not smoke. So this one is given. Probability a student smoke is 0.65, meaning that 65%. Okay, 35%, which is in probability form 0.35 who do not smoke. Okay. Okay, for the next round, the next number, if the first student smokes, the second student also possibility for second student to smoke, also 0.65, and do not smoke is 0.35. So the third student also the same probability like this. Smoke, do not smoke, same probability. Okay, so now first student, second student, third student. So to find, okay, the 3 student who smokes from, kita tengok smoke and smoke. So 0.65 times 0.65 times 0.65. Okay, so this one is 0 means that 0 number of student who does not smoke. So yang ni. Kalau 1 number of student who smoke, so S prime. S prime. So this is 1 number of student who does not smoke. Okay, another 1 number of student who does not smoke from S prime dengan S. Okay. Okay. So kalau 2 number of student who smoke, daripada sini S prime, 2 number of student who smoke. Okay, S prime, SS adalah 1 number of student who smoke. S prime, SS, 1 number of student. Okay, S prime, S prime, S dengan S prime, 2 number of student. S prime, S, 2 number of student who does not smoke. And S prime is 3 number of student who does not smoke. So kita dapatkan probability distribution 0 number of student yang ni, 0 number of student which is SSS. So kita darab probability dia ni, dapat yang ni daripada 0.65 times 0.65 times 0.65. So we'll get this. So untuk 1 number of student, so 1 number of student kita ambil yang ni 1 dengan 1. Okay, untuk dapatkan 1 ni adalah 0.65 times 0.65 times 0.35. Okay, so that is 1 possibility. So plus, so kena plus. Okay, plus untuk another 1. Another 1, 0.35, 0.35, 0 that time 0.65. So kena tambah. Okay, so probability yang ni tambah probability yang ni tambah probability yang ni, yang satu semua. Okay, so dapat this one. Okay, untuk 2 yang ni. Okay, so dapatkan probability yang ni, tambah dapatkan probability yang ni dan tambah dapatkan probability yang ni. Okay. Okay, sama juga untuk 3. Untuk 3 adalah probability this one. Yang ni darab, yang ni darab, yang ni. Okay, so yang ni, this is the probability distribution. Okay, untuk 0 number who does not smoke, 1 number who does not smoke, 2 number and 3 number who does not smoke. Okay, this is cumulative distribution. Cumulative distribution untuk 0 is this one. Cumulative distribution untuk 1 is 0 plus 1. Mana yang ni darab dengan, tambah. Yang ni probability ni, tambah probability ni. Dapat probability ni. Okay, untuk 2, cumulative probability is this one plus this one plus this one. So, dapat yang ni. At the end, so semua sekali event included, so mesti total equal to 1, which is yang ni tambah yang ni, tambah yang ni, tambah yang ni, equal to 1. This is cumulative. Nanti kita akan tambah daripada start pada 0, 1, 2 and 3. Total must equal untuk cumulative distribution, probability distribution, total must equal 1. Okay, conditions of binomial experiment. So ada conditions ataupun ada criteria that need to be defined for a binomial event or experiment. A random variable that represents the number of successes in a series of trials has a probability distribution called the binomial distribution. Okay, so if we have a number of successes in a series of trials, then we call it the binomial distribution. So the conditions are the experiment must meet these conditions, which is a fixed number of trials are conducted. Mesti tetap bilangan trial of events or experiment must be fixed, and there are two possible outcomes for each trial. One is label success and the other is label failure. So macam saya kata tadi, ada two possibilities, yes or no, pass or fail, true or false, macam tu. Only two possibilities. The probability of success is the same on each trial. So setiap probability untuk sukses tu mesti sama setiap satunya. Dan satu trial and another trial tu are independent. Dia tidak mempengaruhi probability yang sebelum. Yang selepas, yang sebelum tidak saling mempengaruhi. Dia mengambil nilai-nilai probability yang sama, kemungkinan yang sama untuk berlaku. This means that the outcome of one trial does not affect the outcomes of the other trials. The random variable X represents the number of successes that occur. So bilangan number random variable tu dia mengambil nilai berapa bilangan kejayaan ataupun bilangan yes yang berlaku, bilangan true yang berlaku, bilangan pass yang berlaku, macam tu. Ini maksudnya bilangan successes that occur for event for the whole experiment. N is size of sample, berapa bilangan eksperimen yang kita lakukan, berapa bilangan trial yang kita lakukan. Okay, for notation is simbol-simbol yang kita akan gunakan for the binomial distribution. Okay, in a binomial experiment, the following notation is generally used. The number of trials is denoted by N. N is number of trials, berapa bilangan sampel yang kita buat, berapa bilangan eksperimen yang kita lakukan. Okay, that is we call it number of trials. The probability of success is denoted by P. P kita gunakan untuk probability of success. The probability of failure is 1 minus P. So kalau kita dapat success, so another kemungkinan yang fail tu adalah 1 minus P. Okay, sebab the whole event, the whole experiment probability is 1. Kalau pass P, kalau fail is 1 minus P. Sometimes Q is used to represent 1 minus P. X represents the number of successes that occur. Okay, so remember kalau sebut X saja is the number of successes that occur. If X equal to 1, kita maknanya berapa bilangan yang berjaya, trial berapa kali. Okay, X represent the number of successes that occur. So X ni adalah berapa bilangan kejayaan yang berlaku daripada how many trials yang kita buat tu, out of n trials, how many yang success. So that will be X. Kalau X equal to 0, no successes occur. Kalau X equal to 1, there is 1 successes out of 10 trials, for example. Okay, be sure that X and P both refer to the same category being called a success. Okay, so kalau P itu kita refer kepada bilangan sukses, jadi X itu adalah bilangan sukses. Okay, example, when an adult is randomly selected, there is a 0.85 probability that this person knows that Twitter is. Suppose we want to find the probability that exactly 3 or 5 randomly selected adults know of Twitter. Does this procedure results in a binomial distribution? So yang ni adalah binomial distribution sebab sama ada dua kemungkinan. The adult know Twitter or do not know the Twitter. So this is success is know a Twitter. Do not know Twitter is a failure. Okay. So what is the probability? X equal to 3. Okay, so now so maknanya sekarang ni apakah probability yang bilangan adult know the Twitter is, bilangan yang tahu tentang Twitter adalah 3. So kita nak cari yang ni. Okay, trials, how many trials here? Kita tengok daripada sini. To find exactly 3 of 5 randomly selected adults. So bilangan trial adalah 5. Okay, so 3 out of 5 selected adult know Twitter. So it means that n equal to 5 trials. Each trial has 2 outcomes. Know Twitter is 0.85 given, which is P, and does not know Twitter is 0.15, which is Q. Okay, so now what is the probability? 3 out of 5